Hello and welcome to your first lesson in Unit 2 of our Integer Operations unit. So our first success criteria for the day is to model integers using two color counters. So before we can do that, we have to have some vocabulary so we know what an integer actually is. So the first number that I want you to think about, or the first vocabulary I should say, is this thing that says whole numbers. So the whole numbers are the numbers that you count with plus 0. So when you counted things as a child, you would often say, I have 1 cookie, or I have 3 dolls, or I have 6 Legos. And it wasn't until a little later that you started to figure out that if you had nothing at all, that you could assign the number 0 to that. Later, which is now, whole numbers are not enough because sometimes we need to talk about when we're digging a hole as opposed to building above ground, or if we're going backwards in time versus forwards in time, or we're going beneath the sea level versus above sea level. So we can arbitrarily set our 0 and then either go above or below it. And when we do that, we need to have a way to talk about the numbers that are below 0. And those numbers, when they are the opposites of our whole numbers, are called integers. So the integers are comprised of all of the whole numbers, which you can see here, 0 through 4, and we have some of those numbers that are positive. So these 1, 2, 3, 4, and on and on and on, those are called our positive numbers, and we're going to use blue in our notes to represent those positive numbers. They are all the numbers that are greater than 0. If we go less than 0 and we do the opposites, these ones are called the negative numbers. So those are the ones that go underneath 0, they go to the left of 0, they represent things that are smaller than 0, and we are going to represent them using red. So there are two different ways that we're going to be representing our numbers when we are working with counters, which is what our goal is here. With the counters, instead of having a blue side, they've got a yellow side. So we're going to let the yellow be the positive, and we're going to let the negative be the red. But when we're taking our notes, because yellow's too hard to see, we're going to use blue for that positive value. The last thing that we need to know vocabulary-wise is what a zero pair is. So a zero pair is whenever you put a positive in with a negative. So you have a positive blue circle and you have a negative red circle. And when you put those together, or with an integer counter, you put a yellow with a blue, or a yellow with a red, excuse me, you end up having a pair that cancel each other out and they're equal to 0. So when I say they're usually stacked vertically, that means we usually put them one on top of the other, and that allows us to see them super quickly as opposed to having them scattered all over our boards. So this is going to be our 0 pair. So once we know our vocabulary, we're set up to model the integers in 3 different ways, or as many ways as we want. So if I want the positive integer 2, I can think about putting 2 blue circles on my paper. That would be the positive integer 2. I could do it with my counters off on my boards by just doing 2 yellow. So this would also be the positive number 2. Now the question asks us to model it in 3 different ways. So how we think about getting things that are equivalent to 2 is by adding some zeros into the mix. So if I keep my original 2 that I have, and then I add a 0 pair, I haven't changed the value at all. All I've done is make it look different. So this 0 pair can get tacked on, and I still have the 2 plus 0, that's still going to end up equaling the positive 2. And that could be the case no matter how many of these 0 pairs I put on. So if I want to do it another way, I could do my normal 2, and then I could put, say, 4 0 pairs on. It doesn't really matter how many I do, because as long as they're zeros, I can use as many or as few as I would like. So in this case, I have 4 zero pairs that I've added on. So this is equivalent to a 2 plus 4 zeros, which is still 2. We can see that on our boards. If we want to build it by hand, we can take a zero pair, which is any 2 that would stack. So here is a 2, and this is also a 2, and this is also a 2. I can build my 2 as many ways as I want. The same holds true when we move into the negative side. So if I want to model a negative integer, say in this case a negative 2, that means I'm going to do 2 counters that are red, and then I'm going to add however many zero pairs on that I want. So I could add 2 zero pairs here. This is still going to equal a negative 2, and I've just added on a couple of zero pairs, and I still have 2. We can do it another way since they ask us for 3 different ways. Here's 4 zero pairs. If I wanted, I could have done 5 or 6 or 7 or 1 or 10. It doesn't really matter. So here I've got a negative 2, and then I'm adding a bunch of zeros. So what I see on the page is still negative 2. Likewise, if I build it over here, if I want to build a negative 2, then I would need to put some red counters down. So here's my first way of writing a negative 2. I can keep the value equal to negative 2 if I just add some zero pairs on, however many I want. So this will still be a negative 2. So if we look at number 3 in our notes, it says, how many different ways can one integer be modeled using 2 color counters? Well, the answer is an infinite number of ways. Because you can add as many zero pairs as you want.